Our first program in this guided activity is to use a naive prime method, and in this process to capture the execution time for computing prime numbers. Now, we'll receive a number in the command line, and what we want to do is to compute and print all the prime numbers less or equal with the received number. And for this, we want to use a naive method in which we'll test each number from 2 to n if it is prime or not. And to test if such a number is prime or not, we'll use one of the definitions that the number needs to be divisible only with itself and no other number from 2 to k minus 1. So the only divisor of will be k for that number. Now, if k does not have any number that will divide it entirely, then it is a prime number. If there is such a number, it's not a prime number. And what we want to, as we identify prime numbers, we want to print them, let's say 10 per line. Now, also we want to compute the execution time for the entire program. So let's get started and try to create the structure of our program, which are the main steps. So first of all, we'll need to read the number to which we compute the prime numbers and is referred to n. Then we'll consider for each number from 2 to n, check if it is prime. Then we'll do that by and I'll put here for each number k, so it will reflect the requirements. So for each number from 2 to k minus 1, check if divides k. And we'll have two cases. If yes, it is not prime. If not, it is prime. And in that case, what we'll like to do, we like to also print the number. Now, that's the main algorithm, but also we like to capture the execution time. And generally, you don't capture the execution for the reading, but for the method itself. So let's mark the start of the execution. And also let's mark the end, or mark the end of the execution, and compute the total time. So this will be the main algorithm for our first analysis: compute and print the total time. And we'll use a similar one for better algorithm, and we like to compare how faster those will run.